Hey, Taiping Airlines Math and History, and we're going to be looking at comparing equations. And for this video, we have a problem that includes comparing two equations, and we also have an animal problem. In ancient China, during the Qing dynasty, the last emperor of China, named Puyi, was just a 3-year-old when he rose up to the throne. And when he was 6 years old, he got visitors in the Forbidden City. The Forbidden City is in Beijing, China. So pretty much, when there were visitors from another country, Emperor Puyi was given a cricket.
Look! Cricket, where's the cricket?
He is my friend, Your Majesty. Safe and warm under my arm. Kept me company on the long journey here. See? He is kowtowing to Your Majesty. Now he can be the Emperor's cricket.
The visitor gave Emperor Puyi a cricket, but not just one cricket. He accidentally gave Emperor Puyi a bunch of crickets, and they accidentally got loose in the Forbidden City. And crickets were not the only problem. Elephants were also brought in the Forbidden City too, and they're also loose. So they're stomping around, destroying the Forbidden City. But Emperor Puyi got very confused. He asked how many animals were brought to the Forbidden City, and how many of the animals were crickets, and how many of the animals are elephants. So, the man from the different country informed Emperor Puyi that he brought 39 animals to the Forbidden City. Let's let X be the number of crickets and Y be the number of elephants. The man also informed Emperor Puyi that crickets have 6 legs and elephants have 4 legs, and the 39 animals have a total of 180 legs. Emperor Puyi wants to figure out how many crickets are there out of the 39 animals, and how many elephants are there in the 39 animals. That's what Emperor Puyi wants to know. Before the animals destroy the Forbidden City, we gotta catch them somehow. So in order to solve that problem, we gotta use comparing equations. And that means we have to compare these two equations and see what number that can be inserted into both of them would make these equations true. Here's an example. Let's make a ratio table with the 4 equations on the top. So here's the ratio table for this problem and that problem. The reason why it's called comparing equations is because we're comparing two different kinds of equations. And the goal is to find a number that would be both plugged into them to make them both true. So let's get started. Let's insert some numbers in this one. So x plus y equals 39. We get to be creative. So let's try 10 and 29. 10 plus 29 does equal 39. But does it work for this one? Remember, our target is 180. And if this combination does not work, it will not work for the whole problem. So pretty much, we have to make sure this is true and that is true. If one is true and the other one is false, then that's not going to work. 10 plus 29 is 39, but here's 10 for x and 29 for y. 6 times 10, that would be 60. Plus 4 times 29, that would be 4 times 29 is 116. So if we have 60 plus 116, will we get to 180? Let's try and figure that out. Our answer would be 176. That is close, but our answer has to be 180. So this does not make our target, which means these two numbers do not work. It's true for this equation, but it's not true for this equation. Let's try a different combination. Type in the comments below what you think should go in here. Let's try and put another combination into this equation and see if it works for this one. So we're using trial and error. Let's try 15 plus 24. So we're guessing that there are 15 crickets and 24 elephants. But if we try and do it on here, will it work? So 6 times 15 is 90, and 4 times 24 is 96. So 90 plus 96, if we do that, we get an answer of 186. We're getting close, but that is not our target. We need a target that's exactly 180. So does this and this work for this? Yes, but does it work for this? No, this does not work either. Just to notify you, X represents the crickets, Y represents the elephants. Crickets have 6 legs, elephants have 4 legs, and the total number of legs in the animals are 180. So let's try 12 and 27. If there were 12 crickets and 27 elephants, that would equal to 39. 12 plus 27 is 39. But does it work for this one? Let's see. 6 times 12 is 72, plus 4 times 27, that would equal 4 times 27 is 108. So 72 plus 108, our goal is 180 as our target. If we add those two together, we will get 180. That would work because 180 and 180 would work. So yeah, does this combination work for this equation? Yes. And does it work for this equation too? Yes. So you know what that means? We have solved how many crickets and elephants are out of the 39 total animals. So because with comparing equations, we need to make both equations true with the same numbers that were plugged in. So our final answer is Emperor Puyi has understood that there are 12 crickets and 27 elephants. That would equal 39 animals in total, which the man had brought to the Forbidden City. And 72 plus 108 is 180. 72 represents the number of legs for crickets, and 108 is the number of legs for elephants, which is 180. The man also said that the 39 animals have 180 legs. So we did it! There are 12 crickets and 27 elephants loose at the Forbidden City. I am so glad that we have saved the Forbidden City from animal destruction. So, when Emperor Puyi was a 6-year-old, he got the cricket, but he was forced to abdicate the throne in 1912. That means he had to give up the throne, causing the Qing dynasty to end. But when Puyi grew older to an adult, he went back to the Forbidden City and found out his cricket was still alive and was still there, because he kept the cricket in a secret location.
Understand? Got it.
Well, I used to live here too. That is where I sat.
Who are you?
I was the Emperor of China.
Prove it.
This is the Hall of Supreme Harmony, where the emperors were crowned. The last emperor to be crowned here was puyi. He was 3 years old. He died in 1967.
Thank you for watching Taipei Airlines Math Industry. Like and subscribe.